All right, hi students. Before we get into the actual business of differentiation, let's do some recall. Right, first of all, let's try to recall what is a tangent line. So a tangent line is actually a line that touches the curve at only one point. Let's look at some examples. Right, so this is a tangent line. We see that it touches the circle at only one point. Another example, this is a tangent line, it touches the curve at only one point. So that particular point is actually called the point of contact. This is called the tangent point of contact. This point here. Wait, hang on. This point here is called the point of contact. Tangent point of contact. All right. So the questions that we should be asking ourselves is that how do we find the gradient of this tangent line? Right. So if you were to recall that you have learned something in your E-math, right? Started with a curve and then with a tangent line. And then I think your teacher would have asked you to prepare a very long ruler, right? And try to place the long ruler as close as possible to the point that you're interested in, right? So if you're interested in this point here, place the long ruler as close as possible to the point and draw the best tangent line. And then what's the next step you do? You identify 2 points on the straight line, right? And to find the gradient of that tangent line, you just apply the formula, which is y2 minus y1 over x2 minus x1. So now the questions to ponder is there another method of finding the gradient instead of having to keep drawing, straight line? Sometimes you may not get a very accurate one. Is there a more accurate way of finding the gradient of a tangent point? The gradient of a tangent line of any point of interest. And the answer is yes, there is. And this is what this video is all about. We're going to learn how to use the concepts of differentiation to find gradients of tangent lines at our point of interest. Right, so now we have come to the interesting part. I'm going to show you how to find the gradient of a curve at any point, right, using differentiation from the first principles. Let's start off by having a curve, right? And then the name of this curve, that's y equals to x squared, is a quadratic curve. Next, let's start off by having a line. Right, this is not a tangent line, okay, because this line actually cuts the curve at 2 points. So this is not a tangent line, right? So on this line, we have 2 points. Point Q, where the x coordinate is x. So when you substitute x coordinate x into y equals to x squared, the y coordinates will become x squared. And we have a second point. We call it Q, right? And Q has x coordinate x plus h. And when you substitute x to be x plus h into y equals to x squared, naturally, the y coordinates of point Q will be bracket x plus h close bracket squared. Right, so let's see what happened. So how do you find the gradients of PQ? Yes, the gradients of PQ will be using y2 minus y1 over x2 minus x1, right? And then you simplify further, right? You expand your bracket x plus h close bracket square. You get x squared plus 2xh plus h squared minus x squared, and the denominator will end up getting h because x minus x gives you 0, right? And if you simplify further by extracting the common factor h out from 2xh plus h squared, you end up getting the gradient of PQ to be 2x plus h. Okay, so far so good. Right. So this is something they've done before. Right, but here comes the tricky part. Right. So what we're going to do is, oh my God, okay, never mind. This thing comes out too early. Never mind, just ignore it. Okay, right. So what we're going to do is imagine that this point Q, right, is going to go very near to the point P. Right. It's just like, give an example. All right. It's just like you want to try to get close to these favorite persons of yours. Okay, could be, I don't know, somebody you like and you want to try to get close to that person. So it's like this point Q trying to get close to point P. So what happened? So when Q try to get close to P, then of course the distance between P and Q for the x coordinate, it's the difference is by this letter H, right? H is the difference. H is the difference between the x coordinates of P and Q. It's like a difference between you and your favorite person. Okay, so when this Q, right, gets very close to P, that means the distance between Q and P gets very close to 0. So it's like saying you want to get close to the favorite person of yours, but if the favorite person of yours doesn't like you, then you can never get near to, you can never touch her or him, whatever. You see, you just manage to get close only. So this is exactly what is talking about here. When your Q get very close to P, the distance between Q and P tends to become 0, but it does not become 0. Okay, which I don't also quite understand. So the limit of the gradients of PQ can be written as the huge thing there. All right, so what it's trying to say, it's, okay, this part here saying that this point Q wants to get very close to the point P, and hence the gradient of PQ, right, when we take the limits of the gradients of PQ, right, somehow this beautiful symbol appear, right? So that is the symbol to find differentiation. That means to find okay, dy over dx is actually read as you differentiate y with respect to x. So what this beautiful symbol here means is, okay, it gets a little bit of takes a while to understand it lah. So dy over dx means that you differentiate y with respect to this variable x. Okay, and when we find dy over dx, when you differentiate y with respect to x, okay, in this example here, in using this first principle, okay, you're actually taking the limits of this point Q going very close to point P, and that becomes the gradients, and the gradient of PQ, which we found earlier on to be 2x plus h, right? So when we take limits of this 2x plus h, right, when we say that, you know, when h tends to become 0, that means you get very, 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 very close, right? What you get is just 2x. So 2x becomes the gradient, at point P. So 2x is the gradient at point P. Or rather, it's called the gradient function. Right? It's not the gradient, it's a gradient function. So depending on what the x coordinates of P you can just substitute. If your x coordinate of P is 3, then you substitute 3 into 2x. So the gradient will be 6. That means when at point P, when x coordinate is, did I say 3? Yeah, then the gradient will be 6 of the tangent line. Okay, will be 6. Okay, I don't know whether I've confused you further or I've actually make you understand. Right, so not to worry if you don't quite understand. Let me summarize for you. So this is what we have done just now. We started off with having a quadratic curve where the equation is y equals to x squared. We have a tangent line and we have a point P. So this point P is actually called the tangency point. What's it called? Tangent point of contact. All right. And we managed to use first principle, all right, to find the gradient functions of this curve, which come out to be dy dx equals to 2x. So your dy dx is a gradient function, right? And it's a very, very effective way of finding gradients at any point. So for example, right, if you want to find the gradient of that tangent line at point P, right, if you want to find the gradient of the tangent line at point P, then what do? So the gradient of tangent line at point P, you just have to substitute into this guy here that we found early on, right? 2x. So you just substitute your x to be 2 because the x coordinates of a point P is 2, right? So therefore the gradient of this line, right? The gradient of that line, right, at point P where x equals to 2, it's 4. That means the gradient of that line is 4. Right, so in other words, okay, do you remember the general form of a straight line equation? The general form of a straight line equation is y equals to mx plus c, right? This guy here, the general form is y equals to mx plus c. So if you substitute your gradient to be 4, that means this guy here, the equations of this tangent line is y equals to 4x plus c. All right. And then okay, to find your c, then you can refer to the earlier on videos I've done on straight line equations. Basically, you just substitute your x coordinate to be 2, y coordinates to be 4, and then you find your unknown c. Okay, right. So let me give you another example. Let's say a second example where you want to find. So now your point P, the x coordinate of point P becomes 3, no longer 2. So of course your tangent line will look different from the earlier when your x coordinate is 2, right? It will look like steeper a bit, right? So how do I find the gradient of this tangent line? So similarly, like what we've done earlier on, we just substitute into y equals to dy over dx equals to 2x. So in this case, in this case here, blah blah blah. In this case here, oh my god, I cannot even. Okay. In this case here, the gradient of this tangent line would be 2 times 3 equals to 6, right? So therefore, the equations of this guy here will be y equals to 6x plus c, right? How do you find the c? Okay, never mind, I just show it to you again. So you just have to substitute your y coordinate to be 9, your x to be 3 plus c, right? So from there, c is your y-intercept value, okay? 9 minus 18 gives you negative 9. So therefore, the equations of that tangent line will be y equals to 6x minus 9. Okay? So this is how effective using differentiation to find the gradient function. Basically, once you have this gradient function, it's like a formula like that. Okay, it's a formula that you can use it to find the gradient of tangent line at any point on the curve. Right, so there are different notations that you have to take note of while finding these gradient functions, this dy dx. Right, so I'm going to show you the three different notations to remember. What are they? So let's do a recap first. So earlier on, we know how we have gone on to find using the first principle to find your dy dx. And dy dx is actually read as you differentiate y with respect to x. So if you were to draw the diagram, right, what you're saying is that on the y-axis, you label it as y. On the x-axis, you label it as x. Right. So when you differentiate y, right, with respect to x, you get dy dx. So if you're going to label the y-axis as a and then the x-axis as t, then your dA over dt would be you differentiate a respect to t. Okay, right. So the three notations are these, the three different notations. So first of all, it's the one that we've just learned earlier. If your equation is y equals to x squared, then your gradient function will be dy dx equals to 2x. Okay, it will be dy dx. If you were to label your, instead of labeling as y equals to x squared, you label it on the y-axis as f bracket x, and on the x-axis is x, then your gradient function would be f prime. Can you see? This is pronounced as f prime. F prime of x. F prime of x. All right. The third one will be, sometimes you just go straight to the point. You just use the symbol d horizontal line dx, whatever the equations of your curve is. So let's say if your equation is y equals to 2x to the power of 5, sometimes they can just straight away do it this way. Right, so what we are saying is that you are going to differentiate 2x to the power of 5, right, with respect to x, and then your gradient function will be 10x to the power of 4. Okay, this is what it means. Right, so you have to take notes of all these three different notations. They mean the same thing. Okay, that means finding the gradient functions of the curve that you're given. Right, so let's come to the important part. Okay, so if you have not been paying attention for for the first few slides, right? Okay, fret not. Okay, from now on you just pay attention. So what's the rule? Right, so if you have I'm going to use a third notation. So the rule is like this. Right. Okay. Right. So what you do is n is a power. So you bring down the power. You multiply it with your x, and then your power minus 1, where n is a real number. All right. So let's have an example. Let's say if you want to find the gradient functions of x to the power of 3. So what do? You just, the power, recognize that the power is 3, just take down 3, right? Usually I like to put bracket, and then x, and then the power minus 1. So that will give you 3 bracket x squared, and of course it's just 3x squared. Okay, that looks simple, right? Let's try another one. Let's say if I want to differentiate square root x. So of course, I need to convert your square root x to x power half first. Right, so bring the power, recognize that the power is half, so take down the power. Right, and then the power minus 1. Yeah, I don't need the bracket there. So half minus 1 will be negative half. Okay, then we need to convert your x to the power negative half into your positive into positive index notation. So that will be half times 1 over x to the power half gives you 1 over 2 square root x. Okay, not difficult. Let's try again. If I want to find the gradient functions of 1 over x squared, what do? Yes, you need to convert your 1 over x squared into your negative. Basically, you just need to convert it into this form. Okay? Ayo. Alamak. Ah. Okay, you just need to convert it into this form. All right? X to the power of something. X to the power of something. So 1 over x squared doesn't work. So you need to convert it to x to the power of something. So it becomes x to the power negative 2. Okay, so what's the step involved here? The power will be negative 2. Take down the power. And then power minus 1. So that gives you negative 2 times x to the power of negative 3. Okay, we need to convert it back into a positive form. So that will be negative 2 over 1 times 1 over x cubed. give you negative 2 over x cubed. Okay, so far so good. How about if I need to find the gradient function of 1? Now, 1 means, what does 1 means to you? 1 means y equals to 1, right? So if you have y equals to 1, we're talking about horizontal line, right? So what is the gradient of a horizontal line? The gradient of a horizontal line will be 0, isn't it? Right. But if you don't believe me, which you should, we can convert 1 as x to the power of 0, right? X to the power of 0 gives you 1, right? Okay. Then you can apply the rules, bring the power down. So anything times 0 will just give you 0, right? Isn't it? So you don't even have to use, okay, you don't even have to use the rule when you are differentiating a horizontal line, because basically y equals to 4 equals to 6, y equals to 8, where a is a real number. Horizontal line, the gradient will be 0. Okay, so you can refer to your textbook for some questions to practice on. The next slide will be doing something more difficult. Right, so what we have just learned is you can find the gradient functions of x to the power n using this formula, right? So how about if you have k f of x? Okay, remember, so what happens if there's a constant in front of it? If there's a constant in front of it, then what do you do? Actually, if there's a constant in front of you, all you need to do is just pull out the constant. And then you just differentiate your f of x. All right, give you an example. Okay, just to give you an example. Let's differentiate. Wait, I think my example, given f of x is equals to 2x to the power of 4. Okay? Basically, k is just a constant, a scalar multiple. It's a scalar multiple, it's just a constant only lah. So if you're given like that, right, so how do you, can you still apply the rule that we have learned earlier on? Yes, of course you can. So your f prime of x, right, so you just ignore your 4. Ignore the 2, the constant. You just work on this guy. So you need a bracket there lah. You just bring down the 4x, then 4 minus 1 give you 3. And then you just multiply these two. Bracket means multiplication. Just multiply them, you get 8x to the power of 3. Okay? So here what it means is that you differentiate 2x to the power of 4. You just take out your 2 and then you differentiate x to the power of 4. So you differentiate x to the power of 4, you get 4x to the power of 3. And you get the same answer. Okay? Right. We can extend this knowledge further. All right. Extend it to what kind of knowledge? Extend it to something like this. Okay? Right. So I'm going to give you an example. Let's say if you're asked, if you're given y equals to x to the power of 4 plus square root 5 x minus 4 over square root x. Then you ask to find dy over dx. Okay, so can you do it? Yes, of course you can do it. All right, so dy dx will be, differentiate this guy. Remember the rule? The power is 4. Oh, okay, wait. Before we differentiate, let's do some simplification first. Very important. You need to do some simplification. Oh my God. Okay, you need to convert this into this format. Okay, always remember that. Convert whatever equations you're given into the raw format. This is called the raw format before you apply the rule. Okay, so this x to the power 4 is x to the power 4 lah. You don't need to convert it lah. Okay, so this one here means square root 5, then x to the power half, right? This guy here means 4, and then x to the power negative half. Okay? All right, so now we have converted. We can find your dy dx. Okay, power 4, bring it down. Power 4 minus 1, 3. Okay, bring the half down. So it's square root 5 times half. Okay, inside your brain, square root 5 times half will give you square root 5 over 2. Then half minus 1 will give you negative half. Okay, when you do differentiation, I'm so sorry, you really need to do some mental calculation. Because if not, you will be writing steps and steps and steps and steps. Okay, the next one will be, see the next one, this guy here, okay? This guy is negative 4. So you bring negative half down, right? You bring a negative, or you can use a calculator. Negative half times negative 4. Okay, how much is it? Negative half times negative 4. That gives you positive 2, right? So plus 2. And then your negative half minus 1 will give you negative 3 over 2. Okay, now we convert it all into positive form. All right. Okay, so my advice to you is that differentiation actually is not difficult. The difficult thing is having to deal with all this algebra. Seriously, all this algebra. Okay, so you have forgotten your indices, the rules of indices. Like square root. This one here. This is equals to a to the power of n over m. Things like that. If you have forgotten it, right, my advice to you is really go and do a revision. Okay, you must go and revise all this stuff again. That will help you a lot. Okay, in your this differentiation, this topic.